Hello and welcome to Engineer Simple. So in this video I'll show how to write Boolean expressions. So let's do an example. So let's assume we have, I would recommend watching previous videos related to logic gates and so on and so forth, truth tables. So if we have an AND gate that takes an input of X naught and Y, then it's fed into an OR gate. Then we have the second input. We have an OR gate that takes X and Y naught, and this is fed into an AND gate, and we have Z, and this is fed into the OR. So we're trying to figure out what is the outcome of this OR gate as a function of X, Y, and Z. So this AND gate here, X, so we can write the output of it as X naught. Since we have an AND gate, it's a dot and Y. Then here, OR, so we have X, OR, so OR is plus sign, or operator, Y naught. So then this AND here, the outcome of it, the first input is X or Y naught. Then we put the AND operator and Z. So this OR, in terms of X, Y, Z, it's equal to X naught and Y. Since this is an OR gate, so I'll put the plus operator, X or Y naught, ended with Z. So that's the expression, for this kind of logic network. Let's look at another example. So let's assume we have an AND gate that takes X, Y, X, Y, and Z naught as input, and this is fed into an OR gate, and the OR gate takes another input as Z, and this here is fed into an AND gate. We have an AND gate here, so Y, Z is input into it. Then this is an OR gate. So the F function, and it has an X naught. So let's assume this is what you have on the FE or PA exam, and you are asked to calculate or figure out the expression for this kind of circuit, logic circuit. You're going to have some choices, 4 choices. But what I'm going to do is I'm going to show how to evaluate this to get the right answer. So first I'm going to start kind of from the back. So like this AND gate here. So this is what I'm going to evaluate. So it has X and Y and Z naught. So X and Y and Z naught. Then I'm going to go to the next logic gate, OR. So this takes 2 inputs, X, Y, and Z naught, or Z, which is this here. So this OR gate, basically, this is what I'm representing it with. So now I got to this AND gate, so I'm going to go back and evaluate this AND gate here. So this is what I'm going to evaluate. It takes two inputs, Y and Z. So now I'm going to go to this AND gate. So basically, the outcome here is it has this input and this input. So X and Y and Z naught or Z. So that's the first. And the AND gate, it will be represented by the dot operator, YZ. Now, the outcome here for this OR gate, I'm going to come down and write it. So F X, Y, Z is equal to the first input, which is X and Y and Z naught, or Z and Y and Z, and I can write this is as one input, or X naught. So that's the expression. That's the expression for this logic circuit. In the next example, or in the next video, I'll do how to do the reverse. You are given an expression and you try to draw the logic circuit. Until then, thank you and take it easy.